All right. Hello.
Let's get it cracking. Hey, sixth period. What's
Uh,
up? Welcome to the hit.
Wow. All right. So will you guys get out your assignments if you have not already, please? Are there any problems that you need help with?
All of them.
30 what? I'm hoping you're talking about 36. 36. Okay. All right, so let's start with 36. Okay, so 36 says find the arithmetic mean of the given term. So can anybody tell me from yesterday how you go about finding the arithmetic mean? Bailey? Yep. You add the 4 and the -3 together and divide by 2. So 4 plus -3 is 1, and 1 divided by 2 is 0.5. Okay? So then for 39, they're trying to trick you because now we got variables in there. But what is -2x plus 2x? 0. They cancel out, and 0 divided by 2 is also going to be 0, so that answer is 0. Okay? All right, what else?
9.
Bailey? Not doing 9. If you're on number 9, then you needed to spend a little bit more time on your own working on the assignment. If you're that confused that you can't even do the first one, please come in before or after school and get help. 42. Okay, so now that we have a formula for explicit formulas for arithmetic sequences, we can take something like this and very easily come up with both an explicit formula and a recursive formula. So for the explicit formula, we start with the first term, which in this case is 0, plus always n minus 1 times the common difference. And in this formula right here, what's the common difference? What are you adding each time? 6. Okay? So the explicit formula would be 0 plus n minus 1 times 6, which you could leave it like that if you want. But for those of you that like things a little bit neater, we don't really need the 0, right? And you could also, if you wanted to, distribute the 6 so it becomes 6n minus 6. So this answer is okay, but this answer is a little bit easier on the eyes, okay? All right, then the recursive formula, remember, is the formula that always relates to the term before it. So you're going to always start with a sub n equals a sub n minus 1. And what are you doing to the term before it to get the next one? Adding 6. So it's going to be a sub n equals a sub n minus 1 plus 6. All right? So now we have the power to do both. All right? I refuse to do number 45. You should be able to do that on your own based on what we have done already. I will help you get started on 48. What is the common difference there for 48? What are you doing each time? You're adding an 8. And it's easier to see that if you rewrite this as 2/8 instead of 1/4. So you're starting with 0, and then 1/8, and then 2/8, and then 3/8, and so forth, okay? So you're just adding 1/8 each time. So you should be able to use that to come up with both the explicit and the recursive formula for those. So you want a minute to do 45 and 48? Okay, so you guys do those on your own real quick. Okay, you guys got 45 and 48 figured out? Good. Any other questions? 51? Okay, I was just talking to, 52 you mean? 50, I got screwed up. 54, okay. 51 is just kind of an opinion question for you to think about what are the things that are nice about the two different formulas. That's kind of up to you. Hi, Piper. Okay, 54 says find the missing terms of each arithmetic sequence. Okay, so there's a couple of different ways that you can do this. The first way we kind of talked about a little bit yesterday. If I'm trying to get from 10 to negative 11.6 in one step, what would I have to subtract to get from one to the other?
21.6.
Okay, good. So this entire difference is negative 21.6. How many steps, though, do they want us to take to get from 10 to negative 11.6? 4. So to figure out the size of each step, I take the total distance and divide it by 4. So what's negative 21.6 divided by 4?
5.
Negative 5.4, because you have 16 divided by 4 is 4, right? So that's going to be negative 5.4, okay? So to find the missing terms, then, you just go 10 minus 5.4, and then take that answer, minus 5.4, and then take that answer, and go minus 5.4. Okay? Yep, I sure will. And while Josie is working on that, there's a different way that you can do this, and they give you this hint, the arithmetic mean of the first and the fifth terms is the third term. So what they're saying there is that instead of doing that, if I take the average of 10 and negative 11.6, what do you get? What is 10 plus negative 11.6? And crickets. I know that's a tough one. My question is, what is 10 plus negative 11.6?
Oh, I got the answer. Don't say it, anyone. Negative 1.6.
Okay, and then divide that by 2.
To do what?
Because I'm trying to find the average of these two numbers. Okay, good. Thank you, Austin. And that gives you negative 0.8. Is that what you guys got for that one? Okay, so you can find the average of these two ones, and that will give you the middle number. How can I use that process again to get this number right here? Good. Take the average of these two numbers. So go 10 minus 0.8 is 9.2. Divide that by 2, and you get 4.6. Okay? So you can do it that way, or you can do it with the step method. Okay? Hannah, I need you to put that away, please. Turn it upside down, put it on your desk. Turn it upside down. Thank you. Colin?
So, on 57,
Uh-huh.
aren't those all 17?
Nice, yes. On 57, to get from 17 to 17, you added nothing, right?
You had 0.
You add 0. Okay, so if you divide that into,
Divide it into 4 is 0.
still 0, so yep, so all of those are going to be 17. Okay, good. Okay, how about 60, because that is a little bit tricky with the variables in it. What do you have to add to a plus 1 to get to a plus 17? 16, yeah. And then again, this would take us 1, 2, 3, 4 steps. So each step is just going to be 4. So then what would A3 be in this case?
5.
A plus 5, and then the next one would be A plus 9, and so forth. Okay, does that make sense?
No.
What's confusing to you about that, Josie?
Oh, you just add 4?
You just add 4 each time. We figured out the common difference was 4, yeah. Okay, anything else? Going once?
Wait.
I'm waiting. Going twice? 57? Nope, you missed that one. We talked about it already. Colin?
51.
51. Okay, we kind of just talked about, it says what are the advantages of each one. I feel like the explicit formula is easier to use, but it's harder to come up with. And the recursive formula is easier to come up with, but harder to use.
I just asked that because that was the one I didn't answer.
Okay.
I couldn't remember
Okay.
what it was.
Yeah, it's just kind of an opinion question. It just wants you to think about the strengths and weaknesses of each one of the different types of formulas, okay? Okay, will you pass those forward? And you guys get out your Plickr cards. My 6th period class, since it's not going to work out on the video, will you guys just get out a blank sheet of paper, and I'm going to have you just answer these the old-fashioned way by hand, okay? Okay, so again, sixth period, you guys can just answer these on a separate sheet of paper and turn them in. We're going to have, I think, 5 of them today. Fourth period, though, you guys get out your cards. And
the answer.
so the first question is, which sequence is an arithmetic sequence?
I got it. Yeah.
Okay, I'm seeing a lot of green. That is awesome. Cole, yep, got it. Yep, because you got it all figured out. Okay, perfect. Looks like about 100%. The answer there was A, because this is going up by 3 every time. So remember, in arithmetic sequence, you have to add the same thing each time. All right, so let's get a little trickier here. An arithmetic sequence begins with 4 and then 9. What is the 20th term? So you're going to have to do a little bit of scratch work here. Probably come up with the explicit formula and then plug in 20. So it might be on a piece of paper. Just hold up your card, call them when you got it. Oh, you have a question? Okay.
I wonder, where has Bailey been?
She transferred to 6th period. Too many Baileys, too many Hannahs. We had to like shake things up a little bit, so we got rid of a Bailey. Jordan and Jordy are lucky to be in the same class together. And there you go. You're fine. All right. Is that pretty much everybody? Oh, Cindy. Thank you. A couple more waiting. Jamie. Perfect. Noel. Okay. Okay, so this one was a little bit tricky. Hopefully you didn't just add 5 on there a whole bunch of times. The key is if you start at 4 and you want to get to the 20th term, you have to add 5 onto there 19 times. So instead of just going 9 and then 14 and then 19 and so forth, if you go 19 times 5, you get 95, and then 95 plus 4 gives you 99. So the correct answer there was 99. So we're almost 100%, not quite. Okay, next one. What are the missing terms of the arithmetic sequence 5? And then there's 2 empty spaces in there. 62. Okay, so 5 space space 62. By 3, yeah, it takes 3 steps, not 2. Kendall, will you move your finger just a little bit? Thank you. Gotcha, Jennifer. Yeah, if you were getting confused because you were finding thank you, Cindy, dividing it by 2, remember that it actually takes 3 steps to get from 5 to 62. So you take that difference and divide it by 3. Awesome. Okay, good deal. All right, so from 5 to 62 is a total of 57. 57 divided by 3 is 19. So if you go 5 plus 19, you get 24, and then add 19 onto that again, you get 43. So the answer to that one is C. Okay, everyone got it. Yep, you guys are doing great. You guys are doing a really good job. All right, 2 more. No, 1 more, because that's the same one as the last one. All right, last one. The 7th and 9th terms of an arithmetic sequence are 197 and 173. What is the 8th term? What is the one right in between? Do ya? Yeah, you got it. Yeah, I got you. I think you need to go easy on Nate, though, Joseph. I think he's getting tired of losing. It's affecting his self-esteem a little bit. Gotcha, Jamie. Thank you. Move your fingers, Hannah. Okay. Is that everybody just about? Cindy, you got it? There we go. Bailey, I didn't get you. Oh, Bailey, that's the other Bailey. Okay, good job. All right. So yeah, Maddie said it right from the beginning. Since we're only missing one term, you can just add those together and divide by 2. You're basically taking the average, and that works out to be 185. Okay. I don't know. Okay. Oh, if you got it wrong? Yeah. Well, then it's embarrassing for the one person that did. Oh, I don't see any.
No, it's still at check mark.
Huh. Oh, reveal answer. There we go. Oh, well, see, now we have to feel bad for the, yeah. Oh, so you just. Oh, so you had it flipped over? Okay, all right. Okay, so she had it. Thanks, Joseph, for clearing that up. Okay. No, right, just with her card, not with the math, so no big deal. Okay. All right, so today we are going to talk about the other kind of sequences that have been coming up in our lives, and those are called geometric sequences, okay? And any guesses what a geometric sequence is?
No, not graphing.
Not shapes, not graphing.
Woo! Triangle.
Not triangles. You guys are, hold on, time out. You are focused on the word geometry. What you should be focusing on instead is that arithmetic sequences involve repeated addition. Geometric sequences, right, involve multiplying and dividing, okay? And so for this, what we're going to do is instead of having a common difference, we're going to have what we're going to call a common ratio. So whatever you're multiplying by is going to be our common ratio, which we're going to use the letter R to stand for that, okay? Please understand that just like with the arithmetic sequences where you can add a negative and it still counts as adding, when we are talking about geometric sequences, instead of talking about dividing, how can you divide using multiplication? You're going to multiply by, multiply by a fraction, okay? So when you're multiplying by a fraction, you really end up dividing, okay? So again, the couple things that you should focus on for your notes is this little formula right here is the recursive formula. Again, the recursive formula is very simple. You just take the term before it and multiply by the common ratio R, so that's no big deal. The explicit formula is a little bit more complicated. That's where you take the first term and multiply it by the common ratio to the n minus 1 power. Because just like when we were doing the arithmetic sequences and you want to add 1 fewer times, you're also multiplying by 1 fewer times than the term that you're trying to find. Okay? So jot that down in your notes real quick, and then we will do a couple of examples. Okay, so first thing, let's identify whether a sequence, Josie? Identify whether a sequence is geometric or not. So, Colin? Yes, okay. And in this case, what is the first term? What is the first term? 3. And the common ratio is? Right, so 2. So you're multiplying by 2 every single time. Okay, how about this one? Geometric or not? What?
No, because it's plus.
Right, this one is an arithmetic sequence because it's plus 3, plus 3, plus 3, plus 3, okay? So geometric is multiply, arithmetic is add. How about this one right here? Is that a geometric sequence or not?
No.
Yes? What are you multiplying by each time?
5.
Mm-mm.
Big number.
It is a big number that you're multiplying by, yeah.
To the n.
Good, 3 to the, yep, 3 to the 5th power. Because remember, when the bases are the same, what do you do with the exponents when you're multiplying? You add them. So 3 to the 5th times 3 to the 5th is 3 to the 10th. 3 to the 10th times 3 to the 5th is 3 to the 15th. And then that times 3 to the 5th would be 3 to the 20th. So that actually is a geometric sequence with the first term, 3 to the 5th, and the common ratio is also 3 to the 5th. Okay, does that make sense? Yes? All right, what else do we have in store? You guys got that. We don't need to practice that. Okay, so now let's use those formulas to find some different terms, okay? So let's say I start with 4, 12, 36, and I tell you that it's a geometric sequence. What would be the, so we're multiplying by 3 each time in this case. What would be the formula that we're using?
N times 3.
What's the formula for this, the explicit formula? Colin, do you have it?
AN equals,
A4, A1 times 3.
A plus N times 4.
You're going, that's the recursive formula. And we're going to use the explicit formula because we want to find the 10th term, and I don't want to multiply by 10, or multiply by 3 that many times, okay?
That's a lot to do in my head.
Okay, Josie, do you have the,
Yes. Is it A1 times?
what's A1 in this case?
Oh, 4.
4,
4 times 3.
right, because that's the common ratio
minus 1.
to the n minus 1. Good. Okay, so that's the explicit formula. And so we're going to use that to find the 10th term. So what do I plug in for n? 10. So I go, the 10th term equals 4 times 3 to the
And
9th power, right? Because 10 minus 1 is 9. And Colin was correct. That's a lot to do in your head. So let's have the calculator do that for us. 4 times 3 to the 9th power means that the 10th term would be 78,732. Okay? So you guys see how to use the formula?
Yep.
Okay, so you know how to identify whether it is a geometric sequence or not. You know how to use the formula.
Hey, Josie,
Okay, so now let's play the same game that we were in the last section. So now it gives you the second and third terms, or no, we need to find the second and third terms of the geometric sequence 2 dot 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 negative 54. So this is a little bit tricky. This time I have to ask myself, what do I have to multiply 2 by to get negative 57, negative 54, I mean?
14, 15,
2 times what equals
24.
negative 54? Good, negative 27, okay? So I know that I had to multiply, I would multiply 2 by negative 27 to get to negative 54. But just like before, we're not doing it in one multiplication, we're doing it in how many? 3, okay? So what I have to do now is I need to take, I'm not dividing this by 3, I need to take the cube root of negative 27 to find out what my common ratio is. And the reason I'm doing the cube root again is because I have to do this in 3 steps, okay? So I want to know what the cube root of negative 27 is. What's that? What? Negative 3, okay? So that tells me that my common ratio is negative 3. So to find the missing terms, 2 times negative 3 is negative 6. Negative 6 times negative 3 is 18. And then as before, the nice thing about these problems is you can check your work. Is negative 3 times 18 negative 54? Yes. So we have successfully found the correct missing numbers, okay? So it's the same process as with the arithmetic sequences, except we're using multiplication instead of addition. So you have to do that. Okay, let's try another one of those because that is a little bit tricky, okay? So let's find the missing term here between 3 and 12. So first step, what do you multiply 3 by to get 12? Okay, so that's 4. Next step, how many steps am I taking to get from 3 to 12? 2. So that means I'm going to take the square root of 4. If it's 3 steps, you take the cube root. If it's 4 steps, you take the fourth root. Does that make sense? So this is going to be the square root of 4, which is 2. So that tells me my common ratio is 2, so the missing number is going to be 6.
Wait, how do you get 6? 3 times 2?
3 times 2 is 6.
Oh, so you multiply by the first number.
Yep, so once you find the common ratio, you take the first number and multiply by that, and that gives you the missing number. Okay? Does that make sense?
Yeah.
Okay. All right, I think that's really all that we have in this section. You guys are on strike against word problems, so let's just cut right to the assignment.
Can you collect this, please?
Jordan is in charge of collecting your Plickers cards.